have called it a diamond. That's kind of an informal word for it. But that is, I think in elementary school, that's probably what you were calling it. I don't know if you called it that in middle school also. Okay, got your figures drawn? All right, so on the rectangle, now let's think why those diagonals come out the same. A little while ago, you were telling me that the corners are 90s. So if I would draw in this diagonal, and let's say this is 8 and this are 6 and 8, how would I find the length of that diagonal?
It's like the hypotenuse.
It's like the hypotenuse of a right triangle. So, okay, so we could do Pythagorean theorem. And what's the Pythagorean triple? 6, 8.
12.
Okay, you two quit. You guys are distracting me. 6, 8, 10. That's a multiple of 3, 4, 5. It's all times 2. So that diagonal is going to be 10. Now I'm going to switch color and go with the other diagonal. So the green one, wouldn't this still be 6, 8, and 10 for the green one? Same Pythagorean triple. So because of the right angles, you're going to come up with the diagonals being the same length. Okay? All right, measure angles. Okay, so those diagonals, when they meet, are they perpendicular? Do they bisect the corners? Do they make a 45 and a 45 in the corners of the rectangle? Do some measuring on some of those angles. Let's see what happens with those. That's 45. 45 in the corner?
I got just.
It's just 36.
I feel like
Okay, over here, the ones that are measuring in the corner, the 90 appears not to be split half and half. It's not 45, 45 at the corners. Okay. How about where the two diagonals meet? Are those 90-degree angles? Okay. No. And here's some measurements, maybe a little bit small, but I definitely have obtuse and acute. The vertical angles are congruent, but they're not all 90s here. And the corners are not bisected 45, 45. If you look at angles, do you notice there are like alternate interior angles that are congruent? So there are some relationships here. We even have those two the same in that triangle. There's some isosceles triangles going on. There are some relationships, but it's not perpendicular or bisecting. I'll show you the diagonal lengths. You told me you thought the diagonals were the same total length, and over here are the totals. Yes, they're the same. Notice that all of these little pieces are the same. Diagonals bisect each other because it's a parallelogram, and they're the same complete total, so those four little ones end up being the same amount. Okay. All right, let's go to the rhombus. So on your rhombus, let's check some of the same things. You should have the two diagonals in there already. Are the two diagonals the same length?
No.
No. And I kind of told you that's how you should create it. They're not the same length. One's skinnier than the other. Are they perpendicular?
Yes.
Probably if you followed what I said to create it, a vertical and a horizontal to draw it, yes, they are. Okay, check the corners. Do the diagonals bisect the corners of the rhombus? Yes, they do? Yeah, they do. So those diagonals are like lines of symmetry. cuts the figure in half, bisects the angles. My picture up here doesn't look too good, but yours on the graph paper where it's accurate. Correct, maybe up here it looks a lot better. So those diagonals do bisect the angles and they're perpendicular. We said they're not the same length. Side lengths. How about the outside side lengths? Okay, let me show you what those are on mine. The edges, they're all the same on a rhombus. That's the definition that we'll have. On a rhombus, all the sides are the same. And the angles are just like a parallelogram. Opposite ones congruent and consecutive ones supplements. Okay, how about your square? Square, specifically the diagonals. Because we should know if you get all the angles in there, especially with the diagonals, you should notice there are a lot of isosceles right triangles, like 45, 45, 90 triangles that we did earlier. There are little ones that are 45, 45, 90. If I do half of it, 45, this whole corner is 90, and that corner is 45. So we've got some great big 45, 45, 90 triangles. So there's some patterns for the side measurements there. So as you were talking about it, a square is a rectangle, a square is a rhombus. Yeah, it's a combination of both of those. So it has a lot of special features to it. All right, let's go to our notes. Put your tools back in the bag.
It's a VIP shape.
It's what?
It's a VIP shape.
Yes. Okay, so back to your notes. Oh, I will. I'll probably come by and pick them up. Somebody left? Oh, we probably should get some new ones. Okay, are we done with this? Keep it, we might need it, yes. You don't have to get rid of everything all the time right away. Just put it to the side. Okay, a rectangle's definition, which is in your notes.
I want 6'4".
You need to write the definition part. A rectangle is a quadrilateral with four good, it doesn't have to. Yeah, so a square is a rectangle. The only part about the definition is that it has four right angles. Okay, there are two theorems about the rectangles. If you look in what I gave you for the notes there. Are you on section 6.4? Go to 6.4, that's the section we're on.
Why was giving 6'3"?
Because it fits better with 6.5 for tomorrow. Okay, so that definition, sorry I didn't remind you about that. But, okay, that definition should be on your 6.4. I guess if you wrote it on 6.3 but not 6.4, transfer it over. Okay, rectangle is a quadrilateral with four right angles. Okay, so here were your theorems. 6.4.1. Screen. Okay, let's do a couple problems related to rectangles. It says a woodworker constructs a rectangular picture frame. We want JK to be 50, JL to be 86, just on your paper. This paper's fine. You'll have it in your notes if you write it on paper. So JK is 50. JL, hard for me to write that in. JL, that diagonal is 86. We're supposed to find HM. So what are some of the thinking things we need to be doing? Clark?
Since JL and KM are, well, because
Okay, JL, that diagonal, and KM, that diagonal are the same. Okay, so KM is 86,
and it's half of it. HM would be half.
and HM is half of it because in every parallelogram, diagonals bisect each other. So half of 86, 43.
Or 40, yeah.
You follow that thinking? Okay, next one. Same thing, same picture, but different information. JK is 21, KL is 72. Find KM. So find this length. Pythagorean theorem, where's there a right triangle? KLM you want to use?
That's KJ.
Okay, JM, you didn't want that one. Which one did you want? KLM. LM. Okay, talk to me some more. Because why? 21 there. What's the other fact I need to have him convince me of before he does Pythagorean theorem? I need to know that it's a right triangle. Can you convince me it's a right triangle? Not a parallelogram, or 90. What figure? Rectangle. The angles of a rectangle are 90. Okay. All right, so then we can do Pythagorean theorem. Who knows what 72 squared is?
Oh, I was gonna
And then square root of 5,026 was 75. So they figured it based on JL, but KM is the same, so 75. The way that we did it would work also. Okay, question on that one. Pythagorean theorem? Okay, rhombus, definition. Morgan, Riley, definition of a rhombus. Rhombus is the one that you weren't as familiar with. We're calling it a rectangle, or excuse me, a diamond shape. The rhombus is a quadrilateral with 4 congruent sides.
Therefore, a square is also a rhombus.
A square is a rhombus. Does a square have 4 congruent sides? Yes. So a square is a special rhombus also. Yes. A square is a rhombus and a rectangle combined. No, it's a very special shape. Okay, ready for the theorems? Okay, here are the 3 theorems related to rhombus. Rhombus, then parallelogram. Yep. Okay, 644, it's talking about the diagonals of a rhombus being perpendicular. The next one talks about the diagonal bisecting angles. So maybe we would call 644, let's see, rhombus, perpendicular diagonals theorem.
I don't know.
I'm pretty much just saying what the theorem says.
I'm just gonna go by the numbers because I don't even have any of the other.
Okay, and 645, we could say rhombus, diagonal angles theorem. Maybe diagonal bisect angles theorem. It might be easiest for us just to say, hey, the reason is in a rhombus, diagonals bisect the angles. All right, got your notes and names? All right, let's try some examples related to that. CDFG is a rhombus. How would we find CD's length? So why is CD equal to the 5A? Tell me what fact. In a parallelogram, are all sides congruent? Parallelogram? No. Parallelograms don't have all sides congruent. Which figure is defined as a 4-sided figure with all sides congruent?
Rhombus.
Rhombus. A rhombus is defined as a quadrilateral with 4 sides congruent. So because it's a rhombus, you would know CD and CG are congruent, and GF, and FD. So all those sides would be congruent because it's a rhombus. So do more thinking.
So,
Why is 5A going to equal 3A plus 17?
sides are the same.
Because it's a rhombus, all the sides are congruent. The definition of a rhombus we're using. Okay, so we would subtract 3a and divide that 17 by 2. So a was 8.5. Now I didn't have the expression for CD, so notice I could put the 8.5 in to the 5 times a, or I could put it into the 3 times a plus 17, either place. I put it into this one, I guess. But no matter which one you put it into, you're going to get 82.5. All the sides will be the same length on a rhombus. 42.5 once you put 8.5 in. Okay, question on that one? Did I say something wrong?
Yeah.
All right.
That's what you said.
All right, my bad. Okay. All right, so quietly think of this one, and let's see how we would reason through it. BTZ, we're trying to find this angle. It's a rhombus. What are some things about angles in a rhombus that could help us? Go with Morgan. This equals 90. Why? Okay, in a rhombus, the diagonals are perpendicular. Are they perpendicular bisectors? Do they bisect each other? Can you give me the theorem that would support that? Nope. 644 doesn't say that it bisects. What's it say? Bisects what? Bisects the angles. That's not what I'm asking. She was saying that the diagonals are perpendicular bisectors of each other. That doesn't mean bisecting the angle. What she's saying is these diagonals are perpendicular and they bisect each other. They cut each other in half. So is this point the midpoint of the diagonals in a rhombus?
Yes.
Prove it to me. What theorem or definition supports it? What theorem or definition supports it? It's not today's material. What am I looking for? Zach?
64.
Tell me the idea.
In a parallelogram, the diagonals bisect each other.
Okay, in a parallelogram, the diagonals bisect each other. Can I use that on a rhombus?
Yes. Yes.
Why?
Because it is parallel.
Because of 643 says a rhombus is a parallelogram. Okay, so that's how we would support it. Okay, so Morgan said we do 14a plus 20 equals 90. Sounds like we're agreeing with that. And so we get a to be 5. Then how do we get to the actual angle measure? How do we get this angle? There's nothing there to help me out.
You substitute in for the angle that is right next to it, which would be
The 5a minus 5, those two are the same? Okay, correct. Because, which one was the one about the diagonal bisects the angles? 645. Some of you are afraid to say the number now. Okay, see the ideas you have to think through. Okay, next one. Okay, look at the next one. Information there. Let's think about how we could figure out what B is so we can do the angles. So this whole angle is B plus 3. This whole angle is 6b minus 40. We're supposed to find GCH. We need this part. Figure out. Ideas going through your head? Colby, got any ideas going? Anything about angles and rhombuses? Read your notes there. Anything we could maybe use? I'm going to take out the diagonals for just a little bit and see if that helps at all. This one was b plus 3, and this one was 6b minus 40. So you're saying this one's b plus 3? Okay. Opposite angles of every parallelogram are the same. You can do that for both of those. Okay, that is probably one fact we need. Another idea, Erica?
And then, to find out that the
Mhm.
we can just do b plus 3 divided by 2.
Okay, so once we get the b figured out, that whole angle divided by 2 will be the one that we want. Okay. How are we going to find what b is? Kara?
6b minus 40 plus b plus 3 equals 1.
So she's saying these two have to add up to 180? What supports that?
Oh.
Okay, same side interior angles. Do we have parallels? Yeah, because a rhombus is a parallelogram. We have parallels. We even had a theorem yesterday in a parallelogram. Consecutive angles are supplements. 6-2, is that the one that says consecutive angles are supplements?
Yeah.
So yes, that one would work. Her same side interior angles would be an idea also. Okay, so I think we finally figured out we could make them supplements. So what equation would we write?
B plus 3 in parentheses plus 6b plus, or minus 40 in parentheses equals 180.
Okay, so you're not setting them equal, you're adding them to be 180. Okay, so I'm kind of on top of my picture there. So I get b to be 31, then someone said substitute it in, that's 34, and we wanted half of it, so our answer should be 17. Okay, lots of good thinking involved to come up with, did you see the 17 there quick? 17 was the angle, I went too far back. 17. Okay, square, we've talked about it a lot. We said it's really special. Definition somewhere, either on that page or turn the page. A square is, as we said, a combination of a rectangle and a rhombus. So it has 4 right angles and 4 congruent sides. So what? No. Still 6-4. Just the last part. And we are out of theorems. But didn't we say, yeah, rhombus theorem applies to a square, rectangle theorems apply to a square. From yesterday, parallelogram theorems apply to a square. So a square has a lot of theorems that you can use on it. Quadrilateral, yeah, it is a quadrilateral. Okay, you've got a lot of space on the back side of what you're taking notes on. We're going to write this one down as much as we can. Okay, that's not what it's asking. It says it's a square. Show that the diagonals of the square are congruent, perpendicular bisectors of each other. Okay, so they're telling you it's a square. Write the directions down, write the points down. We're going to go through how you would do this because you are, as a class in whole, are not good about coming back with this kind of problem down. So you need to, and then you're missing those on the test. The ones where you had to calculate like slope for distance and analyze the ideas, you're skipping that. You're missing the next level of thinking. So you're just doing computations. We need to boost you to the next level, which is analyzing. So that's what this type of problem is doing, getting you to the next level of thinking skills. So we're going to try and show that the diagonals of the square are congruent, perpendicular bisectors of each other. We do that a lot by calculating things. On graphs, what have we calculated a lot? Slope, distance. We've also had midpoint. Those 3 formulas we use on graphs depending on what we're trying to do. So out of those three, what's gonna help us decide or show that the diagonals are congruent? Slope, distance, or midpoint? Congruent. Congruent means how long they are is the same. So which formula tells us how long they are? Distance. So for that part, we'll do distance formula. Perpendicular,
That would be
slope.
or something.
Doesn't slope tell you the slant of it? To be perpendicular, do the slopes need to be the same?
No, they need to be the opposite.
They need to be opposite sign and reciprocals, okay? Bisector, we can do that by midpoint. Because if we calculate, let me draw it kind of, if we calculate the midpoint of that diagonal and the midpoint of this one, if that point is the same on both of them, that will show that they bisect each other. They hit at that point and it cuts each of them in half. So we'll be doing every formula. Okay, so what I need you to write down are not necessarily all the calculations, but what we're doing. Okay, step one. Show that EG and FH are congruent. How did I get those segments? Are we doing the sides of the square? Diagonals. So I probably need to flip back to the picture. Notice that FH would be one diagonal, EG is the other diagonal. So one key is don't do the sides, do the diagonals. Okay, and go back 1 second. And by that step one, what formula are we going to use?
We're gonna find the distance.
Got what you need, Zach? Okay, we're going to do distance formula. You probably won't have time to write all the calculations. But what are you going to put with this? Put use distance formula. And if you don't know the distance formula and don't have it written down, grab it from the wall, the top one there. Okay, so I am showing you that's what the distance formula calculates for each diagonal. Are the diagonals congruent?
Yeah.
Yes, so you need to not just stop there, you need to give me a little sentence. Since they have the same length, segment EG and FH are congruent. So this part showed one part of the problem. The diagonals are congruent in a square. Again, you don't have to have every little calculation there, but what formula and how it comes out typically. Okay, another part, we said perpendicular. We were going to use what formula? Slope. So ready for the next screen? Second step, show that the diagonals, EG and FH, are perpendicular. And you're going to write use what formula? Slope. Use the slope formula. Or if you're not getting down what you need to. So the second step is showing they're perpendicular using slope. So here's the slope of each diagonal. What relationship did we say they needed? To be perpendicular.
They needed to have opposite.
Opposite sign and reciprocal. So are they opposite signs? One's positive, one's negative.
Yes.
Are they reciprocals? Yes. If you multiply them, you get -1. That's how the theorem says. So be sure to finish it. I wrote it in this way. Maybe you want to say since 1/7 and -7 are opposite reciprocals, EG and FH are perpendicular. So I showed it like the theorem does. If you multiply them and it's -1, that shows that they're perpendicular. Okay, so we've done congruent, perpendicular, and bisectors. So what formula did I say could work for the bisecting part? Midpoint. So the third part, show that those diagonals bisect each other. And what formula are you going to use? Midpoint. Use the midpoint formula. Make sure you're doing the midpoint of the diagonals. So each diagonal has -1/2, -1/2 as the midpoint. So that's a common point. That's where they intersect. That point cuts both diagonals in half. So since they have the same midpoint, they bisect each other. See that? That doesn't show any thing except that you can grab points. So show by supporting with calculations. That's the type of problem we're working on. Understand the process.
Yeah.
Some are finishing notes here. Still need it? Okay, so let's see what else I had. I had another one of those. So what are the steps? Step one is?
Distance formula.
Okay, distance formula to show they're congruent. Step two, slope to show the perpendiculars. And step three, midpoint. And make sure you're doing all